Biblical dating. No, not that kind of dating. This video is concerned with dating techniques, and I hope to show you how archaeologists and others date things, the methods used, how they were developed, and the reliability of these methods. As always, I urge you to take nothing as fact, but to check everything for yourselves. I should start by addressing the question, why bother to date at all? I think it was John Archibald Wheeler who said, time is what prevents everything from happening at once. Well, in archaeology, paleontology, etc., accurate dating is what prevents everything from having happened all at once, or in the wrong order. If you're interested in what happened when, or just in what order, then you need to be able to provide an accurate date. Whether it's dating artwork to expose forgeries, holy relics to prove their provenance, ancient cities to determine their place in history, or religious sites to support the biblical narrative. Unless you can support your claims of antiquity or chronology with well-proven dating techniques, your claims will not be taken seriously. Before going into detail on techniques used in dating, I'll start by looking at the general question of the age of the Earth. The "when did it all begin" question has probably been pondered for as long as the "why did it all begin" question. Many biblical scholars have used the Bible itself to date the creation of the Earth. This was based on the ages of biblical characters and the belief that the Bible was inerrant and divinely inspired. For centuries there was no way to verify these attempts at dating. Of course, for many people this was not an issue. The age of the Earth was an article of faith and beyond question. But there were those with inquiring minds, both atheists and theists, who sought ways to either confirm the biblical narrative or simply use deductive reasoning or scientific methods to determine the age of the Earth. For instance, Edmund Halley, he of comet fame, and without whom we might never have had Newton's Principia. Halley was an atheist, which appears to have hampered him only slightly, though it did cost him the post of Savilian Professor of Astronomy at Oxford, a post that was taken by David Gregory. Who? Yeah, I know. Halley was the first that I can find who tried to apply science to the question of the age of the Earth. In his 1715 paper, he hypothesized that the age of the Earth could be determined by calculating the rate of salination of the seas and lakes. He proposed that the salinity of the Earth's waters be measured immediately, and the process repeated at long intervals, such that the rate of salination could be determined. But Halley did not propose a date for the creation of the Earth. Perhaps the earliest stab at that was taken by John Phillips in 1860. Phillips was the nephew of William Strata Smith, Strata, as he was considered the father of English geology. Smith had been raised by his uncle, and in turn he raised his nephew Phillips. And Phillips put forward that the time required for the deposition of stratified rocks was between 38 and 96 million years. Around this time, the religious fraternity were taking an interest. They'd stood by a 6,000-year-old Earth, as detailed in the Bible, but the apparent evidence of geologists was starting to contradict this. Amongst those making serious attempts to reconcile science and religion at this time was Edward Hitchcock. Now, Hitchcock was a noted geologist and a creationist. He was state geologist for Massachusetts and carried out the first statewide geological survey of that state. He's also credited with producing the first Tree of Life, a paleontological tree of the animal and vegetable kingdom set against geological periods. He dropped this tree from his publications after Darwin's publication of The Origin of the Species in 1859. Hitchcock rejected atheism and evolution, but he fully accepted the scientific method and therefore rejected the six-day creation story. Instead, he reinterpreted Genesis so that the days of creation might become vast time spans. In 1862, a giant of science wades into the question of the age of the Earth, none less so than William Thomson, better known to history as Lord Kelvin. Thomson received his lordiness in part for his considerable contribution to the eventual success of the first submarine transatlantic cable. This IT revolution of 1866 brought transatlantic internet speeds of almost a byte every 3 seconds. That would have allowed me to upload this 421 kilobyte image of the first ever colour photograph in about 18 days. But I digress. In his 1862 paper on the secular cooling of the Earth, secular here referring to the long period involved rather than it being a non-religious view of things, Thomson, Kelvin, was indeed a deeply religious man for whom chapel was part of his daily routine. But in this paper he calculated the age of the Earth based on the cooling rate, and he gave a range of 20 to 400 million years. and many others around this period started to provide estimates based on the deposition of sedimentary rocks, with figures generally coming in below 100 million years. In 1893, King and Barris stated that 24 million years was required to explain tidal stability. This figure was accepted by Kelvin in 1897, who then placed limits at 20 to 40 million years. And in 1899, the astronomer George Darwin, son of Charles, stated that much more than 50 to 60 million years was required to explain the Earth-Moon system's current configuration. But the big change in thinking began with the discovery of radioactivity by Maria Sklodowska-Curie. In 1896, Henri Becquerel discovered that uranium emitted rays resembling X-rays. In 1898, Sklodowska-Curie proved that the rays discovered by Becquerel were emitted by the uranium atom itself and not dependent on any molecular interaction. Now, when in 1903 Pierre Curie and Albert Laborde announced the heat generation of radium, it was realized that this provided a mechanism whereby the Earth could produce its own heat, and thus Lord Kelvin's age of the Earth figures based on secular cooling were now known to be way off target. And in short time it was discovered that radioactivity provided a means for accurately dating rock. Pioneers in the field of radioactive dating were Rutherford and Boltwood. They defined decay series and determined methods for calculating the ages of rocks based on radioactive decay. Put simply, different radioactive elements decay at different rates by the emission of alpha, beta or gamma rays. They decay at a predictable rate, and in decaying they change into other elements known as decay products. We can, for each known radioactive element, detail the decay series, or decay chain, and each radioactive element has a known half-life. That is, the time after which it is known that half of the original element will have decayed into its daughter products. Therefore, by measurement of the proportions of parent and daughter products within a sample, we know for how long the radioactive elements have been decaying, and this provides evidence as to the sample's age. And it is not even necessary to have any of the parent element available. In the event this has all decayed, the daughter products may still be available, and calculations on the proportions of the various decay chain products will still provide very accurate evidence of the age of the sample. Radiometric dating as a science is now over 100 years old, and it has been refined continually. There are dozens of different techniques in use for different materials. The accuracy of these techniques can be checked against each other and against other accurate dating techniques such as dendrochronology, or by simply dating a historical artifact of a known age, and this has allowed for fine calibration of the various radiometric dating methods, and this provides confidence that the age of the Earth is 4.54 billion years plus or minus 1%. Thank you for watching.